A car is travelling at 25 meters per second when the driver sees a tractor blocking the road 100 meters ahead. It takes the driver 1 second to apply the brakes, and the retardation is then 4 meters per second squared. We want to know how fast he's going when he hits the tractor. To make sense of this, a clear diagram will help. Suppose this is the car, and here is the tractor. The car and the tractor are 100 meters apart when the driver sees the tractor, and the car is travelling at 25 meters per second. It takes him 1 second to apply the brakes, so the car will now have moved closer to the tractor by a distance which I'll call d. So at this point the car is still travelling at 25 meters per second, since the brakes have not yet been applied. During the remaining distance, he applies the brakes, and the retardation, negative acceleration, is 4 meters per second squared. We want to know, when he's here, how fast is he travelling. If you look at the diagram, all of the notations used are correct notations for drawing diagrams. Velocities are represented by a single-headed arrow and accelerations by a double-headed arrow. If we consider this first part of the motion to begin with, we could just use the fact that s is equal to ut, distance is equal to speed times time, since there's no acceleration. However, I'm going to proceed using SUVAT. Collecting the information for this part of the journey, using SUVAT, the displacement is what we don't know, we've called it d. The initial acceleration is 25 meters per second. Since there's no acceleration, the final velocity is 25 meters per second as well. There's no acceleration, 0 meters per second squared, and we know that it takes 1 second for the driver to apply the brakes. If we use the formula, s equals ut plus a half at squared, we've called s d, and this is equal to 25 times 1 plus a half of 0 times 1 squared. The whole of this is going to be 0 because of the 0, and you can see that we're now left with s equals ut. The distance is 25 meters, so we now know d is 25, which means the remaining distance to the tractor is 75 meters. Considering this part of the motion, using SUVAT to collect our information, we've now found that the remaining distance is 75 meters to the tractor. The motion starts at 25 meters per second. We want to know the final velocity, and the acceleration is now minus 4 meters per second squared. These four quantities are related by v squared is u squared plus 2as. Substituting in, v squared is going to be 25 squared plus 2 times minus 4 times 75. So v squared is equal to 25 squared, which is 625, take away 600. So v squared is equal to 25, giving us that v is 5 meters per second. So the velocity just prior to hitting the tractor is 5 meters per second.